Hi, everyone. This is Kelly from the Teaching Python podcast. So, bear with me, but lately I've been working on my own language models on a server, trying to code with Python and really get to understand what's happening with the different types of models. And it got me thinking about loops and guardrails. And so, just hold that thought while I process something out loud. So in 6th, 7th, and 8th grade in all basic Python, we teach about loops. We teach about infinite loops, and we teach about definite loops, while true, and for loops. And a loop is just a way to repeat a set of instructions, right? In Python, we use the loops to iterate through data. We use it to automate tasks. We use it to build logic that runs until something changes. And so, for example, if we have a list of languages, English, Spanish, and French, and we loop over that list for language and language list, and then we print that language, we have a list of items, and that loop repeats itself, the same action, printing out that language until the list runs out. And nothing inside of the loop or the list, the way that it's written, changes, right? It doesn't change the loop itself. So even if something goes wrong, for example, if we're doing something with data science and we're looping over a column, if something goes wrong and, for example, we hit a non-value, we can fix it manually, right? We can go in and we can edit the code to adjust to that error, and then that loop doesn't adapt. We, the coders, have to change our code and make the loop run the correct way. The loop in the code does what it's told to. It's very algorithmic, right? Makes sense. But if we start shifting our thinking to AI training and we're trying to teach AI in the terms of a CS education classroom, the structure kind of looks similar, but the behavior of the loop doesn't really act the same. So in machine learning, a training loop runs over and over again, right? It makes predictions, it adjusts, it's checking how wrong or how right, it's adjusting the model each time. And so the code might give an update of its weights and loss in order to make a prediction in the future with this data. So on the surface, it's just a loop, right? But the key difference is like the AI loop is adaptive. Each time it runs, it changes the internal state, right? And that's great. That's great for AI and machine learning because when the data is clean and balanced, it turns out perfectly, right? But if your inputs or your outputs are flawed and the model learns the wrong thing, it just kind of keeps reinforcing that bad behavior. And this is what they were talking about with biasness, right? And so, going back to a few years ago when they had those resumes that were screening and they were hiring from these resumes, the goal was to predict who would be going first, and they had these past resumes, and what happened was like the male resumes were abundant, so most of the people that were male got hired and not the females, and that was because the data wasn't really cleaned or validated in order to identify any bias, right? It didn't just identify the bias, it really reinforced it. And with each loop, the biasness was better. It was more unfair, right? And so there's terms like this. It's like overfitting, bias amplification, something else. I'm not going to go into that. But loops are very powerful, right? And the problem is like without these guardrails, without the right code in there, they can kind of spiral out of control. And here's the thing, right? Most of us, we're not training our own models. We're just going in there and we're using a model that has already been developed with these trained loops and their own data. And so we're not tuning these neural networks on our local machines. So our job isn't building the loops, but we need to recognize the bad loops in there. And that means we really need to teach the students, where did this AI learn? Is it repeating the bias? Is it generalizing from the truth? Is this an output that's helpful? Or is it just saying that it's really smart and it knows what it's talking about, so I should believe it? And so the guardrails that we can put on if we're not coding is that, the infamous critical thinking or the prompt design, and to be aware. And so we need to help the students see when an AI loop might be stuck or learning too much from the wrong resource. So here's the real connection when you're teaching Python loops, the basic concepts, and automating repetition, and AI, how you make that connection with that automating of the learning. So Python loops, you have to debug them, you have to make sure that the output is what you wanted. And AI loops, you kind of need to debug them as well. You need to make sure that the output is what you want. And so that's where we come in as CS educators to teach the kids that regardless if it's a Python basics loops or an AI loop of information, we need to validate that the information that's printing out or returning from the loop is what we want it to be. And that's all I have to say. So for Teaching Python, this is Kelly signing off.